From the air, they appear as ribbons of colour, hugging the edges of continents and islands. These are fringing reefs, vibrant ecosystems teeming with life. Fringing reefs are a wonder of the natural world. They are a testament to the power of nature to create beauty and complexity. These underwater cities are home to a dazzling array of marine life. Fish, corals, invertebrates, and countless other creatures find refuge and sustenance in these vibrant habitats. Fringing reefs are the most common type of coral reef. They are found in tropical and subtropical waters around the world. These reefs form close to the shore, creating a shallow lagoon between the reef and the land. The clear, warm waters of these lagoons provide ideal conditions for coral growth and marine life to flourish. Beyond their beauty, fringing reefs are essential for the health of our planet. They are crucial to both marine and human life. Their intricate structures provide a home for a quarter of all marine species. These reefs act as natural barriers, protecting coastlines from erosion and storms. They are a source of food and livelihood for millions of people around the world. Imagine a powerful wave crashing against a coastline. Now picture a fringing reef standing strong, absorbing the impact and protecting the shore. This is just one of the vital roles these underwater ecosystems play. Fringing reefs are nature's coastal guardians. They act as natural breakwaters, reducing the power of waves and protecting coastlines from erosion. The coral structures, with their rough surfaces and intricate shapes, dissipate wave energy. This buffering effect helps to prevent damage to beaches, coastal communities, and infrastructure. Without these natural barriers, coastlines would be more vulnerable to the destructive forces of the ocean. Storms, hurricanes, and even rising sea levels pose significant threats to coastal areas. The protection offered by fringing reefs is not only crucial for human settlements, but also for the diverse ecosystems that thrive along coastlines. Mangrove forests, seagrass beds, and other coastal habitats benefit from the calmer waters created by these reefs. These interconnected ecosystems rely on each other for survival. The loss of one can have a domino effect on the others. Prepare to be amazed as we delve into the underwater world of fringing reefs. These ecosystems are bursting with life, a kaleidoscope of colors and shapes in constant motion. Fish dart in and out of coral branches, invertebrates crawl along the seafloor. And above it all, the corals themselves, a living tapestry of intricate forms and vibrant hues. Fringing reefs are home to an astonishing diversity of marine species. They are considered one of the most biodiverse ecosystems on Earth, rivaling even rainforests in their variety of life. From microscopic plankton to large predators like sharks, the reef supports a complex web of life. The corals themselves are animals, not plants, despite their often plant-like appearance. They form symbiotic relationships with tiny algae called zooxanthellae. These algae live within the coral tissues and provide them with food through photosynthesis. In return, the corals provide the algae with a protected environment and the compounds they need for photosynthesis. This delicate balance is essential for the health of the reef. Fringing reefs are the most commonly found type of coral reef, easily distinguished by their close proximity to land. Unlike barrier reefs, which are separated from the shore by a lagoon, fringing reefs grow directly from the seabed near the coastline. Imagine them as vibrant underwater gardens bordering the shores of continents and islands like a living fringe. These reefs are a testament to the intricate relationship between land and sea. The shallow waters of the lagoon between the fringing reef and the shore create a unique habitat. This area, often protected from strong waves and currents by the reef itself, provides a nursery for many marine species. Young fish, crustaceans and other creatures find refuge and sustenance in these calmer waters before venturing out to the open ocean. The lagoon also serves as a feeding ground for larger animals such as sea turtles and rays, which visit the reef in search of prey. The close connection between fringing reefs and the land also means they are easily accessible for humans. For centuries, people have relied on fringing reefs for food, livelihoods, and cultural significance. In many coastal communities, fishing on the reef is a way of life passed down through generations. The reefs also provide recreational opportunities such as snorkeling, diving, and boating, attracting tourists and supporting local economies. Section 2. A delicate balance, ideal conditions for growth. The vibrant colours and bustling life of a fringing reef mask a delicate balance of conditions required for their growth and survival. Like all coral reefs, fringing reefs are built by tiny animals called coral polyps. These polyps secrete calcium carbonate, forming the hard skeletons that create the reef structure. However, this process is highly sensitive to changes in water temperature, salinity, light, and nutrient levels. Fringing reefs thrive in warm, shallow, and clear waters. Tropical and subtropical regions, where sunlight can easily penetrate the water column, provide the ideal environment for these ecosystems to flourish. The optimal temperature range for most reef-building corals is between 23 and 29 degrees Celsius or 73 and 84 degrees Fahrenheit. Outside this range, corals can experience stress, leading to bleaching and even death. The clarity of the water is also crucial for fringing reef health. Corals rely on sunlight for the photosynthetic algae called zooxanthellae that live within their tissues. These algae provide the corals with essential nutrients, and their presence gives the corals their vibrant colours. Sedimentation, pollution, and other factors that reduce water clarity can block sunlight, hindering photosynthesis and harming the reef. Section 3. The first line of defence: fringing reefs as coastal barriers. Beyond their ecological significance, fringing reefs play a critical role in protecting coastlines from the relentless forces of the ocean. Acting as natural breakwaters, these underwater structures buffer the impact of waves, storms, and erosion, shielding the shores and the communities that call them home. The intricate topography of a fringing reef with its coral branches, crevices, and lagoons disrupts the flow of water, reducing wave energy before it reaches the shore. As waves approach the reef, they encounter the shallow reef flat, causing them to break and lose energy. The remaining wave energy is further dissipated as the water flows over and through the complex reef structure. This buffering effect protects beaches from erosion, prevents flooding in coastal areas, and safeguards human settlements and infrastructure from the damaging impacts of storm surges. The protection provided by fringing reefs is particularly important in the face of climate change. As sea levels rise and extreme weather events become more frequent and intense, the value of these natural barriers increases exponentially. Protecting and restoring fringing reefs is not only crucial for the health of marine ecosystems, but also for the well-being of millions of people living in coastal communities around the world. Section 1. The birthplace of a reef. The formation of a fringing reef is a captivating story of life, death, and renewal. It begins with a solid foundation for a new coral colony. This could be a submerged rock platform, the slopes of an extinct volcano, or remnants of an older reef. The foundation must be stable for coral larvae to attach. These larvae drift through the water, carried by currents in search of a home. They need warm, clear, shallow water with sunlight. The larvae attach to the hard substrate. They transform into coral polyps, the reef's architects. Success depends on a balance of factors. Water temperature must be optimal for coral growth, typically between 23 and 29 degrees Celsius, or 73 and 84 degrees Fahrenheit. Water must be clear for sunlight to penetrate. Symbiotic algae photosynthesize to provide energy. Water must be free from sedimentation and pollution. Pollution can smother coral polyps and impede growth. Once settled on their new home, the coral polyps get to work, embarking on a lifelong endeavour of construction. These tiny animals, resembling miniature sea anemones, extract calcium carbonate from the surrounding seawater. They then secrete this mineral in the form of a hard calcium carbonate skeleton, creating a protective cup-like structure around their soft bodies. This skeleton forms the foundation of the coral colony and, over time, the reef itself. As the coral polyps grow and multiply, they continue to secrete calcium carbonate, gradually expanding the colony both vertically and horizontally. New polyps bud off from the parent polyps, forming a connected network of individuals that share nutrients and resources through a thin layer of tissue. This interconnectedness is key to the success of the colony, allowing them to withstand environmental stresses and build a more resilient reef structure. The shape and structure of the coral colony are influenced by a variety of factors, including the species of coral, the wave energy of the surrounding water, and the availability of sunlight. Some coral species form branching structures, resembling underwater trees, while others create massive, boulder-like formations. The intricate shapes and crevices of the growing coral colony provide shelter and habitat for a diverse array of marine life, further enriching the biodiversity of the developing reef. The formation of a fringing reef is a slow process. Coral growth rates vary, with massive corals growing up to 2 centimeters per year. Branching corals grow faster but are more susceptible to breakage. The expanding coral colony creates a complex habitat. Storms and disturbances create rubble, but also new opportunities for colonization. New coral colonies emerge, adding to the reef's resilience. Fringing reefs are not monolithic structures. They exhibit remarkable diversity, influenced by local conditions and coral species. Some develop as narrow bands along the shoreline, while others extend offshore. The reef flat, slope and lagoon create diverse habitats. High wave energy forms an algal ridge, protecting delicate corals behind it. Calmer waters favor branching corals, creating habitats for fish and invertebrates. Water depth and clarity influence coral distribution. Shallow waters support diverse corals, while deeper waters harbour unique communities. The interplay of these factors creates a fascinating tapestry of life on fringing reefs. Imagine diving beneath the surface of a tropical ocean, the sun's rays dancing through the water, illuminating a world of vibrant colour and bustling activity. This is the realm of the fringing reef, a marine metropolis teeming with life. From the smallest invertebrates to the largest predators, these underwater ecosystems support an astonishing diversity of species. A living tapestry woven with intricate patterns of life, each species playing a vital role. Fish, adorned in dazzling hues, dart among the coral branches. Schools of tiny, silvery fish shimmer like living confetti. Larger hunters, like groupers and snappers, lurk in the shadows, their watchful eyes scanning the reef for prey. Crabs, lobsters and shrimp scuttle across the seafloor. Sea stars crawl slowly across the coral. Sea urchins graze on algae. Anemones sway gently in the current. Their tentacles capture passing prey. Corals, a living architecture of intricate forms and vibrant hues, provide the foundation for this bustling ecosystem. At the heart of every fringing reef lies a secret garden, built by tiny coral polyps. These industrious creatures create complex structures, providing shelter and breeding grounds for marine life. Despite their plant-like appearance, corals are animals, each polyp connected by tissue. The diversity of coral species on a fringing reef is astounding. Massive corals like brain and star corals form the reef's foundation. Branching corals provide shelter for fish and invertebrates. Plate-like corals capture sunlight for symbiotic algae. The health of the coral reef depends on a delicate balance. Water temperature, salinity, light and nutrients are crucial for coral survival. Imbalances can lead to bleaching, disease and death. Maintaining coral health is essential for the entire reef ecosystem. The fringing reef is a delicate balancing act, a complex web of life where each species plays a vital role. Herbivores like parrotfish and sea urchins graze on algae, preventing overgrowth. These grazers become prey for larger fish, maintaining balance. Apex predators like sharks and rays ensure the survival of the fittest. Protecting reef biodiversity safeguards this intricate web of life. The fringing reef is a testament to the power of symbiosis, where species depend on each other for survival. Corals and zooxanthellae share a vital relationship, with algae providing food through photosynthesis. This helps corals grow and build their skeletons. Stress can lead to coral bleaching, turning reefs ghostly white. Cleaner fish remove parasites from larger fish, benefiting both parties. Crabs and shrimp find shelter with anemones, defending them from predators. These relationships create a biodiverse ecosystem. In the intricate dance between land and sea, fringing reefs emerge as formidable guardians. Their presence is a silent but powerful force, protecting coastlines from waves, storms, and erosion. Built by coral polyps, these reefs act as natural breakwaters, absorbing ocean energy. Waves build in the open ocean, only to be disrupted by the fringing reef. The reef's rough surface disrupts the wave's smooth passage. Energy is forced upwards, causing the wave to break and crest. The remaining energy is absorbed as water surges through the reef. This natural buffering effect softens the blow to the coastline. Without reefs, coastlines would be at the ocean's mercy. Waves would erode beaches, carve cliffs, and flood low-lying areas. Coastal communities would face constant threats from the sea. Fringing reefs provide a natural buffer, maintaining the balance between land and sea. Fringing reefs act as natural breakwaters, reducing wave energy through their unique structure. Their shallow platforms slow down waves, causing them to break and dissipate energy. The reef crest, with wave-resistant corals, absorbs the brunt of wave energy. These corals act like living breakwaters, disrupting water flow and reducing wave height. Water cascades down the reef slope, further dissipating energy through friction and turbulence. Fringing reefs are vital coastal protectors against climate change. Rising sea levels threaten low-lying coastal areas. Fringing reefs grow vertically, keeping pace with rising seas. Coral skeletons provide a solid foundation for growth. Corals build skeletons, maintaining reef height. This buffers coastlines, protecting homes and ecosystems. Reefs mitigate storm impacts, reducing erosion. They reduce storm surge power, protecting beaches. This protection is crucial for coastal ecosystems and communities. However, climate change stresses can damage reefs. Rising temperatures and acidification compromise reef protection. Protecting and restoring reefs is essential for our future. The vibrant colors of a fringing reef mask a delicate balance, a symphony of life. Yet this underwater Eden faces a growing threat from warming waters, leading to coral bleaching. Rising temperatures stress corals, causing them to expel their colorful algae partners. Bleached corals are starving and more susceptible to disease. Persistent stress leads to coral death, leaving behind skeletal remains. Beyond the invisible threat of rising temperatures, a more visible menace casts a shadow over fringing reefs: pollution. From the land, a steady stream of pollutants carried by rivers, streams and stormwater runoff flows into coastal waters, smothering these delicate ecosystems with a toxic cocktail of chemicals, nutrients and debris. Agricultural runoff, laden with fertilizers and pesticides, fuels algal blooms that block sunlight, choking out corals and disrupting the delicate balance of the reef. Sewage, often poorly treated or discharged directly into coastal waters, introduces harmful bacteria and pathogens that can sicken marine life and contaminate seafood. Industrial waste, containing heavy metals and other toxic substances, accumulates in the food chain, poisoning fish and other marine organisms, ultimately impacting human health as well. Even seemingly innocuous items like plastic bags and bottles can have devastating consequences for reef life. Turtles, mistaking plastic bags for jellyfish, ingest them, leading to starvation and death. Fish become entangled in discarded fishing nets, known as ghost nets, which continue to trap and kill marine life long after they have been lost or abandoned. The debris accumulating on the reef blocks sunlight, smothers corals, and creates breeding grounds for disease-carrying organisms. The relentless onslaught of pollution, both visible and invisible, is steadily degrading the health and resilience of fringing reefs worldwide. An ocean out of balance, overfishing and the disruption of reef ecosystems. Overfishing threatens the delicate balance of fringing reefs, pushing fish populations towards collapse. Unsustainable fishing practices deplete target species, leading to cascading effects. Herbivorous fish prevent algae from overgrowing corals. Predators keep smaller fish populations in check. Overfishing disrupts this balance, leading to ecosystem collapse. A corrosive future, ocean acidification, and the weakening of reef structures. Fringing reefs face a hidden danger from our carbon emissions: ocean acidification. The ocean absorbs a quarter of the carbon dioxide from human activities. This absorption changes the ocean's chemistry. Carbon dioxide forms carbonic acid, increasing ocean acidity. Increased acidity affects organisms that build shells and skeletons. It reduces carbonate ions, making it harder for them to build. Ocean acidification is a double whammy for stressed reefs. It weakens existing structures, making them more susceptible to erosion. The reef becomes fragile, less able to recover from disturbances. Ocean acidification is altering fringing reefs, jeopardizing their future. Safeguarding havens, marine protected areas and the promise of recovery. Marine protected areas, or MPAs, are zones where human activities are regulated to safeguard marine ecosystems. These sanctuaries offer a refuge for marine life, allowing coral reefs to recover from pollution, overfishing and climate change. Imagine a bustling coastline transformed into a haven for marine life. Fishing restrictions in MPAs help fish populations rebound and restore ecosystem balance. Destructive fishing practices are strictly forbidden. Pollution controls safeguard water quality and marine life health. MPA's benefits extend beyond their boundaries. Recovered fish populations support local livelihoods. Improved ecosystem health enhances tourism opportunities. MPAs protect biodiversity and provide economic benefits to coastal communities. While protecting existing fringing reefs is crucial, active intervention is needed to restore degraded ecosystems. Coral nurseries, underwater gardens where coral fragments are cultivated, are a promising tool for reef rehabilitation. They offer hope for these vital ecosystems. Imagine marine biologists working diligently beneath the waves, tending to coral fragments attached to artificial structures like underwater trees of life. These nurseries serve as sanctuaries where coral fragments are given a second chance. Carefully chosen for their resilience, they are attached to submerged structures, providing a stable platform for growth. Protected from predators and diseases, they grow and multiply. Once large enough, they are transplanted back onto reefs secured with epoxy. The corals continue to grow, rebuilding the reef structure. This process, akin to underwater gardening, requires patience and expertise, but it offers hope for the future. Coral nurseries are vital for reef rehabilitation. They are a testament to human dedication. The challenges facing fringing reefs are global in scale, requiring a coordinated response from nations, communities and individuals around the world. International cooperation through agreements, partnerships and the sharing of knowledge and resources is essential for addressing the transboundary threats of climate change, pollution and overfishing. Imagine a world where countries come together, not in competition but in collaboration, recognizing that the fate of the ocean and the fringing reefs it cradles is inextricably linked to our own. International agreements, such as the Paris Agreement on climate change, provide a framework for reducing greenhouse gas emissions and mitigating the impacts of a warming world on coral reefs. These agreements, though not perfect, represent a crucial step towards addressing the root causes of coral bleaching and other climate-related threats. By working together to reduce carbon emissions, nations can help to stabilize the ocean's temperature and give coral reefs a fighting chance to survive. Beyond addressing climate change, international cooperation is crucial for combating pollution, particularly plastic pollution, which knows no national boundaries. Agreements on waste management, plastic production and recycling are essential for stemming the tide of debris that is choking our oceans and harming marine life. By sharing best practices and technologies, nations can learn from each other and implement more effective solutions to this global challenge. From the air, they appear as jewels of turquoise and azure, vibrant ribbons woven into the fabric of our planet's coastlines. Dive beneath the surface, and a breathtaking world unfolds, a symphony of life orchestrated by tiny coral polyps. Fringing reefs, a testament to nature's artistry, face an uncertain future, threatened by human activities. Warming waters, pollution and overfishing push these fragile ecosystems towards a tipping point. The choices we make today will determine whether these treasures inspire future generations. The time for complacency is long past. The fate of fringing reefs rests in our hands. Just as human actions have pushed these ecosystems to the brink, so too can our collective efforts bring them back from the edge. Each of us has a role to play, a responsibility to be stewards of our blue planet. Let us be the generation that chooses hope over despair, action over inaction. Together we can ensure a future where fringing reefs continue to thrive.